this video, we're going to learn how to tell when a Markov chain is a regular Markov chain by looking at when the transition matrix is a regular matrix. Okay, so first we need to know what it means for the transition matrix to be regular. So a transition matrix is regular if some power of P has only positive entries. Okay, so some power, it doesn't have to be P itself, okay, but some power of P. If a transition matrix, if a Markov chain has a transition matrix that's regular, that's when we know it's a regular Markov chain. So let's just do some examples trying to tell which of these transition matrices are regular. Okay, so for the first one, here's my P1. So notice that it's square. Okay, so it's a transition matrix. It's 3 by 3, so it has 3 states. Each of the rows sum to 1. Okay, so we can tell it's a transition matrix. We just want to know if it's regular. So we're looking to see if some power of P has only positive entries. Okay, now this matrix immediately has all positive entries. Okay, so this is all positive entries immediately, which means that P1 is regular. Oops. So the transition matrix associated with P1 is going to be a regular transition matrix. Now you might be wondering, don't all transition matrices have only positive entries? And you're close to not wrong. So remember, positive, this means greater than 0. Okay, so the entries, you're right that the entries in a Markov or in a transition matrix are always non-negative. So they're probabilities, so they have to be between 0 and 1. Okay, but you might have transition matrices with zeros. Okay, so P2 down here has 4 zeros. Okay, so it's not immediately regular. So what we want to do is compute powers of P2. Okay, so initially we would say this has zeros. Okay, so it's not immediately regular, but it still could be regular. Now, because we only care if the entries are positive, we don't actually care what the entries are, we can use a shortcut and not actually compute them. Okay, so note, I'm going to use a star, okay, but you can use whatever you want to represent a positive entry, positive number, okay? So then if we have a star multiplied by a star, okay, that's going to be a star. 2 positive numbers have to give us a positive number. If I have a positive number plus a positive number, I still get a positive number. If I have a positive number plus 0, okay, this is also a positive number. Now, if I have a positive number times a 0, this is a 0. Or if I have a 0 plus a 0, okay, that's a 0, or a 0 times a 0, that's a 0. So we can use these shortcuts to to compute these matrix powers without actually computing the numbers. Okay, we only care if the numbers are positive. So if we wanted to compute P2 squared, okay, so that's going to be P2 times P2. What we want to do is, instead of you're welcome to actually compute the numbers, okay, but it's going to take way longer to do that. So what I'm going to do is put a star everywhere P2 has a positive number and a 0 otherwise. Okay, so a 0 if there's a 0. Okay, so that's one copy of P2, and then I have another copy of P2, and I want to multiply them together. So when we do our multiplication, okay, we're doing matrix multiplication, so I'm going to try to illustrate this. Okay, so I would take this row and this column, Okay, that's going to give me my first entry. So I'm going to write this out. Okay, so I get a star times a star plus a star times a 0 plus a 0 times a star in my first entry. Okay, when I take this row times the next column, okay, that's going to go here, I have a star times a star plus a star times a star plus a 0 and a 0. Okay, and then I would do the last one is that row times the last column. I have a star times a 0 plus a star times a star plus a 0 times a 0. Okay, now I want to do similar stuff with the second row. So I'm going to have a 0 times a star plus a star times a 0 plus a star times a star. Okay, so that was this row, this column gave us that entry there. Okay, now I take that row times the next column. Okay, that's a 0 times a star plus a star times a star plus a star times a 0. Okay, you don't have to write this out every time. I want to illustrate what's going on. So then I have a 0 times a 0 plus a star times a star plus a star times a 0. Okay, now I'm doing with the last row. Okay, so it's a star times a star plus a 0 and a 0 plus a 0 and a star. Then I have a star and a star plus a 0 and a star plus a 0 and a 0. Then I have star and 0 plus 0 and star plus 0 and 0. Okay, now I want to just go through and look for where I might get a star. Okay, so in the first one, star, star, okay, that's a star. Star and 0, okay, that's a 0, and 0 and star, that's also a 0. But when I have star plus any zeros, I get a star. Okay, so this first entry is a star. Okay, in the next one, I have a star plus a 0. So again, I'm getting star. Basically, all you need to do is look for 2 stars. Okay, if you hit 2 stars, then you know you're going to get a star because you're going to be adding a star at some point. Okay, so I can see that in all of them except the third column, third row, I'm going to have star, at least 1 star plus a 0. Okay, in this last one though, I have a 0 plus a 0 plus a 0. So I get a 0. Okay, so far, not all positive. Can I conclude at this point that it's not regular? Nope, I cannot. So what I'd want to do is compute another power. Okay, so I could do P2 cubed. Okay, or you could do P2 squared times P2 squared and do P2 to the power 4. Okay, it doesn't matter. So here I'm going to do P2 squared times P2. Okay, that's going to give me P2 cubed. So P2 squared has the form we just found, so it's almost all stars. And then I want to multiply by P2 as it was. So that was star, star, 0, 0, star, 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 0, 0. Okay, so we want to do our multiplication. I'm going to do it a bit faster this time. So when I take this row times this column, I definitely hit these 2 stars, and also these 2 stars, but hitting 1 pair of stars is enough. This row times this column, okay, the first 2 stars hit. This row times this column, the middle stars are going to hit. Okay, so that means my first row is all stars. Okay, now the second row is exactly the same as the first row. So it's going to hit the same stars as the first row did. So these are also going to be all stars. Okay, now what about this third row? So this row times this one, this column, I'm going to hit these first 2 stars. That's good. This row times this column, okay, these first 2 are going to hit. Okay, that's fine. And this row times this column, the middle ones are going to hit. So I'm going to hit all 3 stars. So that means in my cube, my P2 cubed, we have all positive entries. Okay, so that means that the matrix P2 is a regular matrix because some power of it has all positive entries. Okay, so P2 is regular. That's what we just showed. Okay, let's try another one. So here I only have 2 zeros. Okay, so, but there are some zeros, so I need to do a square at least. So that's going to be star, 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 0, star, 0, star, 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 times star, 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 0, star, 0, star, star, star. Okay, so this is P3 times P3. Okay, now again, I'll write it out, but I'm just going to write out, I'm not going to do star, star. Okay, so if 2 stars hit, I'm going to write a star. Okay, so if we do this row and this column, okay, I get star, star, which is a star, plus star 0, which is a 0, plus star, star. So I'm going to have star plus 0 plus star. Okay, now for the first row, second column, I'm going to have star plus star plus star, because I'm going to hit all 3 times. And in the next row, or next column, sorry, I'm going to hit stars, and then I'm going to get a 0, and then I'm going to hit another pair of stars. So I'm going to get something like that. When I do this middle row, okay, so this row times this column, I get a 0 and a star, that's a 0, a star and a 0, that's a 0, and a 0 and a star. So here I get 0 plus 0 plus 0. When I do the middle column, I'm going to hit the middle stars. Okay, and when I do this last column, I'm going to get all zeros again. Okay, now the third one is going to be the same as the top one. So this is going to be star plus 0 plus star, star plus star plus star, and star plus 0 plus star. Okay, so what we end up getting looks like star, 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 0, star, 0, star, star, star. So we still have 2 zeros. Should I compute more powers, higher powers of P3? I don't actually need to here. Okay, so the zeros are in the exact same spots. Okay, as in P3. So if I wanted to do P3 cubed, I would take P2 or P3 squared times P3. So I'm going to be multiplying this matrix by this matrix. That's exactly what I already did. Okay, so we're going to be stuck with this format. With this distribution of zeros, okay, for all powers of P3. So that means that these zeros are never going to go away. So now we can conclude that P3 is not regular. Okay, so if you get a form that you've already seen, okay, so this one is the exact same as the original one, that's how you know you can stop. Okay, so let's do one more. This one I'm not going to use stars because ones are even nicer. Okay, so if I do P4 squared, it's going to be 0, 1, 1, 0 times 0, 1, 1, 0. Here we can actually compute these. So 0 times 0 plus 1 times 1. Okay, 0 times 1 plus 1 times 0. 1 times 0 plus 0 times 1. Oops. And 1 times 1 plus 0 times 0. So here I'm going to get 1, 0, 0, 1. Okay, so it's not the same. Okay, we have the same number of zeros. Okay, but in different spots. Okay, so we can't stop at this point, although we sort of can because this is the identity matrix. So we can sort of already know what's going to happen when I do the cube, but let's just do it. So I'm going to do P4 squared times P4. So that's the 1, 0, 0, 1 matrix times the 0, 0, 1, 1, 0 matrix. Okay, so that's 0 plus 0, and then 1 plus 0, 0 plus 1, and 0 plus 0. Okay, so here I get 0, 1, 1, 0. Okay, so the cube is the same distribution, but it's actually identical. Okay, same as P4. So because we got this same distribution back, we're just gonna, the powers of P4 will just continually, oh, I missed an N. Continually cycle between these two forms. So between 0, 1, 1, 0 and 1, 0, 0, 1. Okay, so that means that always will have zeros. Okay, so that means that now we can conclude that P4 is not regular. Okay, so it's not a regular matrix. So you might be wondering, you might have to do this a lot of times, right? Obviously, I'm not going to be mean and make you compute really high powers before you get something the same or all the zeros disappear. Okay, so you might have to do 2 powers before they all go away like we did for P2. Okay, but for most of the examples we do, actually, they're going to be all positive right away. Okay, so you might not have to compute powers of P, but this is how you would check if a matrix is regular, which is how we know if we have a regular Markov chain.